Welcome back to Intermediate Studies. In today's video, we will cover important 2 mark questions from Unit 5, which is Laws of Motion, a key chapter for intermediate first year physics. So let's quickly revise the most expected 2 mark questions from this unit. Make sure to take notes and pause if needed. And these are the 8 questions. And out of these 8, we will definitely get one 2 mark question and be confident to answer these questions. So let's get started. So the first question is, what is inertia and what gives the measure of inertia? So we need to write the definition for the inertia, and you also need to give what gives the measure of inertia. Um first look at into the definition. Inertia: if the net external force is zero, the body at rest continues to be at rest and the body in motion continues to be in motion, so with uniform velocity. This property of body is called inertia. Just read this definition 2 or 3 times or 4 or 5 times till you get, until you remember, so that you can answer easily. And what gives the measure of inertia? The mass is the measure of inertia. So for this definition, you will get 1 mark, and for mass is the measure of inertia. For writing this, the word mass is the measure of inertia, you will get 1 mark. Okay, don't forget to write the mass is the measure of inertia. So the next question: can the coefficient of friction be greater than one? Of course. In some reasons, like when we are polishing too much, or in some other cases, the coefficient of friction will definitely be greater than one. See here, I mentioned one reason. As when the contact surfaces or polishes too much, then the adhesive forces between the molecules increases, and the value of coefficient of friction will be greater than 1. First, they are asking can means yes or no. First, you need to answer that, and if it's yes, then you need to write the reason. If it is no, then also you need to write the reason. So, see why it is yes. Because when the contact surfaces or polishes too much, then the adhesive forces between those molecules will increases, because we are polishing too much, right? So the forces between those molecules will increase, so that the coefficient of friction will also be greater than 1. That is the reason. So just remember this highlighted word: contact surfaces or polishes too much, then the forces between the molecules will increases. And next, the third question: why does a heavy rifle not recoil as strongly as a light rifle using the same cartridges? See here, from the law of conservation of momentum, we already know the formula. The recoil of gun V is equals to mu by capital M, where capital M is the mass of the gun. If you see here, V is inversely proportional with the M, which means recoil of the gun is inversely proportional to the mass of the gun. Recoil of the gun is inversely proportional to the mass of the gun, which means if the mass of the gun is increases, then recoil will decrease, right? Because inversely proportional, if the mass will increases, which means mass of the gun is increases, the recoil of the gun will definitely decreases. That is the reason we are describing here. See, due to the heavy mass of the rifle, the recoil is less. Because of the heavy mass of the rifle, the recoil is less. Recoil of the gun is less. So hence the heavy rifle does not recoil as strongly as a light rifle because of its heavy mass. That's it. So don't forget to write this. Because of its, remember this, because of its heavy mass, the heavy rifle is not recoiling as strongly as light rifle. So if you remember this, if you write this formula also, it is well and good, because it will create a good impression and elaborate the answer. Just like if the M is increases, then the recoil will decreases, because those two are inversely proportional. So just write that. That's it. Yeah, fourth question. When a bullet is fired from a gun, the gun gives a kick in the backward direction. Explain. Here also, according to the law of conservation of momentum, when a bullet is fired from the gun, the momentum of the gun is equal in the opposite to that of bullet. According to the Newton's third law, what the Newton's third law will define? For every action, there is an equal and opposite reaction. So that's the reason. According to the Newton's third law, as the bullet moves forward on firing, the gun moves back with the same momentum of that bullet. Okay, if the bullet is moving forward, then the gun will definitely come to backwards. That is what we are describing here. So the next question: if a bomb at rest explodes into two pieces, the pieces must travel in opposite directions. Explain. For example, a bomb is at rest. If it explodes, then it two pieces will get into this. The bomb will explode like this only, right? The the pieces must travel in the opposite directions. Why? Explain. Since the bomb is at rest, initial momentum is zero. Explosion is mainly due to the internal forces. So law of conservation of momentum is valid. Here, we all know that explosion is mainly due to the internal forces. What the internal forces will do? Internal forces doesn't affect on the momentum of the body. So that's the reason the momentum before and after explosion is same. Okay, so that's why the law of conservation of momentum is valid. If the bomb explodes into two pieces, the total final momentum will be m1 v1 plus m2 v2 is equals to 0. So if it will goes here, which means m1 v1 is equals to minus m2 v2. Here negative sign indicates that the pieces must travel in the opposite direction, which means this is the first piece and this is the second piece. Because the final momentum is 0, so then both pieces will move into the opposite directions, because here negative sign indicates the pieces are in moving in opposite direction. Hence two parts fly off in opposite direction. Just you need to mention because of law of conservation of momentum, and mainly explosion is due to internal forces, and we need to write the final momentum of the gun is 0. If you haven't remember the formula, just skip this and just you need to write the reason. What is the reason? Like the law of conservation of momentum, if it is initially it is on rest, and if it is and final momentum is also 0. So while explosion it will fly off in the opposite directions. Just give some description, just give some explanation for that. And you can also mention because of the Newton's third law, the pieces will travel in opposite direction. You can also mention that one also. If you haven't remember the exact answer, just give the some description for this, just give some explanation for this statement. Okay, if you will remember this, that is very well and good. Just give this answer only. Yeah, next question. Why does the car with a flattened tire stop sooner than one with inflated tires? See, in case of flattened tires, we are having more deformation. If you are having more deformation, then the area of contact of the tire between area of contact between the earth and the tires are increases, right? If it is flattened, then the angle of contact is more. So that's the reason the flattened tides are stop sooner than the inflated tides. See, in case of flattened, more deformation occurs when compared to that of inflated tides. So due to the more deformation of the tides, the area of contact of the tides increases. Since rolling friction is directly proportional to the area of contact, because for inflated tides we are having less area of contact. If the less area of contact, then it won't stop sooner. So flattened types stop sooner than the inflated types. Just you need to remember this flattened has more deformation. If the more deformation is there, then angle of contact is more. So that's the reason flattened types are stop sooner. That is enough. So the next question. You need to remember these two keywords. Flattened has more deformation. So that's the reason area of contact of the types or increases in the flattened types. So it will stop sooner. So the next question. A horse has to pull harder during the start of the motion than later. Explain. For starting motion of the cart, the limiting friction is to be overcome. This limiting friction is greater than the kinetic friction. Hence, the horse has to pull harder during the start of the cart. Just we need to overcome the limiting friction. To overcome the limiting friction only, we are pulling harder during the start of the cart. Next question. What happens to the coefficient of friction if the weight of the body is doubled? Nothing will happen, because yeah, nothing will happen because the weight of the body is independent of the coefficient of friction. See here, the coefficient of friction is independent of the weight of the body. If the weight of the body is doubled, coefficient of friction doesn't change, so it remains constant. So coefficient of friction remains constant. That's the thing we need to write here. That's it. That's it for this video on 2 mark questions from Unit 5 Laws of Motion. Make sure to revise these questions well. Don't forget to like, share, and subscribe to Intermediate Studies for more helpful videos. Thanks for watching. All the best. Bye bye.